In this video, we're going to take a trip down the alimentary canal. We're going to start our journey much like your food does, in the mouth. And what I want you to notice is that you've got teeth, and you've got different kinds of teeth. You've got incisors, which are the sharp, pointy teeth. Those are for biting and tearing. You've got molars, and your molars are for grinding. And then surrounding those teeth, you have a series of salivary glands. You've got the parotid salivary gland, that's the one here that makes the majority of your saliva. You've got submandibular, that's under the jaw, and then you've got sublingual, which is under the tongue. You also have a bunch of sort of smaller salivary glands around your mouth, and these are going to make saliva. Saliva has several functions in our digestion. One of those is that it kind of compacts the food and helps it come together. Another is that it contains an enzyme in it, salivary amylase, that starts the digestion of starch. If you were to take a piece of bread or a cracker and hold it in your mouth for a long enough time, you'd notice it starts to taste sweet. That's because that salivary amylase is breaking down those starches into simple sugars. Now, also in your mouth, you have your tongue. And what your tongue is going to do is it's going to serve this vital function of kind of stirring the food to help it to mix. And that's really important because what we're trying to do is we're trying to get that food into something called a bolus. And that's what you're actually going to swallow. So by the time your teeth and your salivary glands and your tongue are done with this bolus, it's going to be a smooth thing that can go down your throat. Once you swallow it, it's going to go past a piece of your throat called your uvula. That's the punching bag thing that you see in the back of your mouth. That pulls up and back, and that keeps food from kind of going up and out your nose. Now, of course, this could be overridden if someone tells a really funny joke and you're eating, but it does serve that function. Once you swallow, remember that what we learned in respiratory is your larynx is going to pull up and out from that hyoid bone, and your epiglottis is going to close over the trachea. That's going to help direct the food back towards the esophagus. Once it gets into the esophagus, it starts a muscle movement called peristalsis. Peristalsis is a rhythmic series of muscle contractions. So it's going to contract here, and then here, and then here, and it's going to work that food down towards the stomach. Once we get to your stomach, there's going to be a sphincter. Remember, a sphincter is a circular muscle, and that's the cardiac sphincter, also called the lower esophageal sphincter, and that sphincter is going to open, and that's going to allow the food into the stomach. You also have an upper esophageal sphincter that keeps the food from going down the esophagus before it's ready. You also have another sphincter, which is called the pyloric sphincter, and that prevents the food, or at this point it's called chyme, where it's food that's partially digested, from entering the intestines before it's ready. So you know sometimes when you eat a big meal and you think, how in the world did my stomach fit all of that? If you look closely at the stomach, you'll see ridges. Those are called rugae, and those allow the stomach to expand when you eat larger meals, or, well, when you eat anything, because your stomach isn't going to be in its expanded state at all times. So that's enough stomach anatomy. Now what I want to do is I want to focus on what does the stomach do and how does it do it. So imagine for a second that I asked you to do something. Imagine I handed you a bag of potato chips and I asked you to break it down into the smallest components. You wouldn't just move it like this, right? You would be coming at it from every direction to try to break down those potato chips. This is what your stomach does. So your stomach has several muscle layers, and these are in different directions. There's the circular muscle layer, the longitudinal muscle layer, and the oblique muscle layer. And these layers are going to come together and allow your stomach to move in every direction so it can mix the material. Meanwhile, inside of your stomach, we also have acid, and that acid is going to be breaking down the food. Remember, the extra hydrogens get in the way of hydrogen bonds, and they start to cause things to kind of unwind and unravel. If the sphincter does not close properly, what happens is while the stomach is churning the food and it's moving in every direction, some of that can go back up the esophagus, and since the material in your stomach is really acidic, that can cause discomfort, which we know as gastroesophageal reflux disorder, or GERD. Contents of the stomach broken down physically into really small pieces. Each individual piece has a high surface area, which allows the digestive juices to interact with those pieces and start to break them down. What are the digestive juices? Well, I already mentioned one. One of them is acid, and that acid is released by parietal cells within your stomach wall. There's another kind of cell called a chief cell, and chief cells release an enzyme called pepsinogen. That's its inactive form, but guess what activates it? It's acid. The acid activates that pepsinogen into pepsin, and it creates an enzyme which, when it's active, breaks down proteins. Now, why isn't it active all the time? Well, we don't want to break down the stomach, and the stomach's made of an awfully lot of protein. In addition, the stomach protects itself by covering itself with a layer of mucus. This is done by cells called mucus neck cells, and they're going to release that mucus and keep that protective layer around the stomach. If this breaks down, then the acid can start to irritate the stomach wall, and that can create what we call an ulcer. There are hormonal controls to these cells that make sure that they secrete the right thing at the right time. When you see or smell or taste food, your body starts to release a hormone called gastrin. And gastrin is going to start making those parietal cells secrete hydrochloric acid. It's also going to start making the stomach a little bit more mobile. Once you eat, now that food goes into your stomach, and that's going to temporarily raise the pH because it is very rare that you eat anything as acidic as what's in your stomach. More gastrin will now be released as a result of that higher pH, and that's going to cause more acid secretion, which is going to bring the pH down. That acid secretion is going to start breaking down the food, and it's going to activate that pepsinogen into pepsin so that now you can start to digest proteins. So that kind of sums up the upper GI part of digestion. Now, I want to do a review, Cindy style. And you'll notice that the teeth are moving up and down and chewing something. Uh-oh. Oh no. They're stirring this stuff around and they're compacting it. Oh no, I think I'm going to get seasick. Oh. And there's saliva making everything mix. Now it's down past the epiglottis, down the esophagus, to the stomach where I hit acid and I'm melting.